given a binary tree, and we need to check if binary tree is completed. So first we need to do some clarification, and if a tree is a complete tree, it should not have tree nodes as null unless the tree nodes is on the lowest layer of the tree and the null is on the most right side. So we're going to use the breadth first search to solve this problem, and we are going to traverse all the nodes and check if their child nodes are null. And if once we found a leaf, a node where it's null, we set a boolean to true, and we continue to traverse until we continue to traverse, and if there are more nodes behind, which has child nodes, we need to return false. Otherwise, if there's no nodes and if there's no nodes after the null, we will return true. And we also will build a queue to store these tree nodes. And now we can, and the corner cases is if the tree is null, we need to return true. Okay, now let's start coding. So let's start the let's start the function. So we need to return a boolean as a result, and we call this function as check for, and we will input a tree node root as to represent the tree. And first, let's get the corner case. So if the tree is null, we need to return true. And for other cases, we first need to build a queue. So we will use the interface as queue, and we will store tree nodes inside. We call it queue. And also, we need to initialize a boolean. So we call this boolean as flag, and this flag will help us to check if the return should be null or true. So the flag should be a new boolean. And first we will offer the root into this queue. So and next we need a loop to offer the other tree nodes one by one. And we will have this while loop. Our queue is not empty, so the queue is not empty, and we now define a tree node current as the pulling out the queue, the element from queue. And now we expand this current node, and we will check its child nodes. So if the current's left child is not equal to null, we will add if the current left node equals null, we do nothing, but we turn the flag to true. And else if when the current is not null, but the flag is true, we need to return false. Because the flag is true means there is already a null in previous of this tree node. And else, if none of them is true, we will add this left node inside the queue. So and we also do the same thing to the right node also. And if we offered all the cases and it didn't return true, return false, we need to return the true as a result, which means we don't have any empty spaces in the binary tree. So for this algorithm, the time complexity would be would depend on the number of nodes. So for every while loop, the time is O1, and there are if n is the node number, there are n times of while loop. So the time complexity should be O(n). And the space complexity, we build a queue during this solving the problem. We build a queue, and the maximum tree node number inside the queue should be O(n). Should be n, so the space complexity should also be O(n).